from Serbia has a talk for us. So, please.
I don't have a mic. Okay, so I don't care about those. Okay.
So you don't watch.
Okay, can you hear me? I think it works, right? So, first, I'll try to say something in Russian, because my title slide is in Russian. So, извините, пожалуйста, что мое представление в английском языке. Я не говорю по-русски. I speak English. I did learn Russian in elementary school and obviously forgot everything. So if this sentence doesn't make sense, please don't. Yeah. So the talk is about the continuation monad and how can you do natural task scheduling by using it. First, just who am I? I've been developing KD for almost a decade. Apart from that, I give talks and I'm teaching C++ at my university. And I'm a functional programming enthusiast, but I'm not a purist. So if you see Bartosz running out of the room screaming, it's to be expected. So before we start, one of the things that I tend to do is a disclaimer at the beginning. So one of my favorite quotes by Philip Wadla is that you should make your code readable because somebody afterwards can be a psychopath and he knows where you live. This doesn't mean that you should write programs that are understandable by children. You should write programs that are understandable by professionals like you, and not make your code stupid in order for anybody to understand it. Because I got a lot of complaints that things that we do, including Bartosz's stuff, a lot of people don't understand it. It shouldn't stop you from using them. It would be the same if you were an assembler developer and somebody created C or C++ and you're forbidden to use classes because people who code in assembler wouldn't understand them. So use advanced concepts and force other people to use them as well. And the second disclaimer, because I love disclaimers, is that parts of the talk are really not optimized for anything apart from presentation. So usually I did omit STD namespace and everything else just to show the code on the slides. Okay, so this is kind of continuation talk, a pun intended, from my Berlin talk at Meeting C++, but since I expect nobody has seen it, I will put a shorter recapitulation of what I talked over there, and then continue and expand on the continuation monad and futures. I don't know why I put a bridge of Moscow, but it's a nice picture that I took last night, so enjoy. Okay, so a short introduction to monads in a different way than Bartosz did it, and I'm really glad that he talked before me about this, so I can be quite quick to pass through all these slides. So just alternative way to see a monad is a box that you should not really by default be able to see into. Currently I've shown that you can see it so that you can see what's inside. So one of the methods that a monad should kind of have is a method that takes some object and put it in a monad, and you get a monad that contains that object. But the most important stuff is the transform, as C++ calls it, or the map method. So you have a monad of some object, and that monad needs to know how to apply some function to that object that is contained, and you get a monad with a transformed object. In this case, we have a smiley face. A transformation is painted it in red, and you get a box containing a red smiley. If you had an empty monad or for example, I don't know, an empty list, you would get, after mapping an empty box, if you had one smiley, you will get it painted into red, and the second smiley will have it painted into red as well. The other method that a monad should have is if you have a box of boxes, so a monad inside of a monad, it should be able to flatten it out and pick all the things from inside monads into the outer monad. And I guess you haven't followed anything that I said, but it's not that important. So this is the alternative way to define a monad to Bartosz's thing. Usually, instead of having separate methods for transform and flatten, you have one composed method that is called bind, and it's kind of equivalent. So you can get these methods from this method and vice versa. The question that I also asked in Berlin, who can tell me the differences between these two? Sorry?
In the second case, we can change for each to do something else.
Yes. So the first one is hard-coded to be. You need a begin, you need end, you need everything, and you need to iterate over those. STD for each does similarly the same thing, but you can always define your own for each for something that is not an array or anything else. So essentially, for each can launch nuclear missiles if you wanted to. You shouldn't want it to be in Russia, right? Okay, so one of the reasons why monads can be useful are ranges. So for example, just imagine a method like this. Can you, when you first see it, can you tell me what it does? It's not really obvious. You need to read a large chunk of code just to see that it gets a list of persons, of people, and gets, if, I don't know, it tries to get all the children of females and only children that are aged below 20 years, and it has offset and count. And this method is really hard to read, and it's hard to modify. If you, for example, want to remove the int count, you would need to skim through all the code and just remove the lines that are dealing with the counts. If you use ranges, which are based on monads, you can do something like SQL does, because SQL is kind of a functional programming language. You just filter all the persons which are female, get their children, accumulate all the children into one box, filter, children need to be younger than 20 years, and drop how many elements and how many elements you want to take. Now, if you want to remove the offset part of the method, you just delete one line. This is not really a natural thing for C++ programmers to do, but it's much more convenient than actually to write all the code that we saw earlier. And it's also applicable to other monads. So who knows about the maybe monad and boost optional and STD optional to be? So, okay. Optional is like a value that doesn't need to exist. So for example, if you have a function like a square root, if you pass it a negative number, it cannot return a value. So it would return an empty optional. If you pass it a positive number, you would get an actual value. So it's like an ordinary value, but with in C#, I think it's called nullable or something like that. So something that can contain nothing or just one value, like a list that has no elements or one element. Here we have two methods that return options. For example, if you're accessing a configuration file and you don't have this key inside, you don't have that configuration option, config value should return nothing. It shouldn't return a default value because you didn't specify it. The other thing, if this was invalid integer, parseInt should return, again, nothing. In this case, we need to go after each call, we need to check whether the return value is a valid one or not. If it's valid, if it's invalid, return empty string, and the same thing here. With monads, and in this case ranges, you can do something like this. So this returns an option, you just pass it through transformations, and if at the end you still have an empty option, you just say get value or the default one empty string. So ranges, although unnatural to C++, please start using them. They will be in, hopefully in C++ 17. If not, you have a really nice libraries written by Eric Niebler or Boost Range.
Are these ranges short-circuited?
Sorry?
Are these ranges short-circuited?
Yes, so for example, if you get an empty option here, all of these will just be skipped because you can't apply map or anything to an empty option. So it will just go over there, return you the same empty option as before. So the beautiful thing, I don't need to explain what futures are. Again, the only thing that I want to mention is please don't use .get which blocks. So wherever you see something affects weights in the standard, please don't use that method. In reactive programming and asynchronous programming, you should never make your code wait for anything. It's not only about opportunities to optimize stuff. It's blocking the UI, it's doing evil things. So please never do something like this. .get is really evil. Alternative to .get is .den, which gets a functor or function object if I don't want to insult Bartosz. And you get a future, you call f.get. Here you can call the .get because it's already, the future has already arrived, so it will not block anything because it's in the .den call. The difference between normal monads and future is that .den should not pass you a future of t. It should pass you the value that you got. So if this was designed in a normal sane way, you would not even have to call .get. You would just get the value as the argument. So, so far we have seen during this conference about what futures are. They're kind of, if we have values in present, futures are values in the future. Apart from normal values, we can have lists or vectors or collections of data. But what's on the other side of the equation? Should I put here std future of std list? Does anybody say that I should? If we have a value and future of value, should we have list and a future of list?
Why not? Depends.
In a general case. So it depends. We obviously have cases where it could work, but the problem is that sometimes not all the data that you are going to get in a list is going to be available at the same time. So for example, you're sending a request to Google. It returns chunks of data. You shouldn't really wait until all the data has been sent to you before starting to process it. Instead of having future of list, we have something that is called reactive streams, which is kind of like an object that notifies you anytime a new data arrives. So instead of a future that can only notify you once, a reactive stream would be able to notify you a dozen of times until it stops. And reactive streams are also kind of like monads. So, okay, I can skip this. If you have reactive streams designed like ranges, you can have something like this. Mouse movements, when you move your mouse, it does send you events that your mouse is at this and that coordinate. Again, you cannot get it in a list because until now we have some events and we will have more events in the future. But you can connect that stream and say we should filter all the events so that a scene, the mouse is in some kind of a scene. The second thing, when we have filtered those, we just want to transform them and invert the epsilon coordinates so that we don't use the top left as 0, 0, but bottom left or something like that, and then process all the results on mouse move. In this case, this needs to be a special algorithm for each. It cannot be the range for that C++ standard provides. And now we're coming to the main part. So we said that you should never block your code. So if you have a simple algorithm like this one, if you want to convert it to C++, you would get something like this. So user get username, you check if user exists, or something like that. The problem here is that methods that are marked with orange color, they are blocking. So when you ask the user to do something, or you're doing something more complex, you cannot write it like this. The problem is, as soon as you say get password, your program is blocked until the user actually types something in and presses enter. And what we usually do is create a lot of calls and callbacks, which doesn't really look like the original algorithm that was nicely depicted in the picture. This is the graph that depicts what actually you need to implement. So instead of doing this, you need to implement this. Each of the get username, get a new password, and everything else, you need to split into two because you need a call and a callback, and you don't control your code. You have an event loop or something else that calls your methods when they need to be called, which is definitely not a clean way to design anything, but it's the only way that we currently can. And this is what it looks like from the point of view of George Hart, which is a really nice sculpture creator, whatever it's called. So you get spaghetti code. Okay, because we realized that calls and callbacks are evil, we started wrapping them into different concepts. One of the concepts are tasks like queueThread, spinning off a thread, or std thread, or whatever. From POSIX, you have methods like select, which you can say, okay, let's wait for maximum 10 milliseconds. If you have something for me, pass it on, or just send me I don't have anything, try again. Again, we can have process state or something like that, but what's new and hot are the futures. So these things are just hiding stuff from you, but you still need to deal with a lot of inversion of control, just they're hidden behind some objects. With futures, by default, again, you need to deal with the inversion of control, but you can do something even smarter. Okay, we already saw this one. The problem is that the .then method works currently only on boost future. You have a lot of classes that behave like a future, but are not designed to have a .then method. So for example, a normal integer, it's also a future that is currently present. You cannot call i.then, it's a syntax error. Well, not syntax, but compilation error. You cannot call queueFuture from Qt library as .then because it just doesn't support that method. You cannot, a lot of libraries just don't support .then, for example, for fetching from the internet or anything else. Instead, you need to write things like these. If you want to use I, just use it directly. If you want to use boost future, use it like this. If you want to use Q future, it's the prettiest code that you've ever seen, I guess. You need to re-register a Q future voucher, which should be deleted later when the future arrives and everything else. Just for a simple, let's continue with our result. Because nobody, I don't know, 5 years ago or more, thought about having a dot then in any of the future stuff in C++. And now that we will get dot then, you can do something as pretty as this. But for me, this is still completely unreadable. One of the things Herb Sato talked about was, okay, this makes code localized, it's easy to reason about and everything else, but he tends to use only one continuation, so dot then and something else, and never change a lot of items inside, not to show people that it doesn't really make code readable. It's localized, it's in one single method, but it's still really, really, really nested. And for me, it is ugly. For me, the ideal would be if you could write something like this. The compiler would figure out, is getUsername a synchronous or asynchronous method? If it's synchronous one, behave as usual. If it's not synchronous, wait for the result and then continue with the rest of the code. And before the Await 2.0 proposal, the only thing that was really possible is that you couldn't really achieve that syntax because C++ doesn't allow you to overload everything. You could make something like this. So you have a serial block which executes all these tasks serially. Again, if this is a synchronous one, it will execute immediately and then call the next one. If it's not synchronous, it will wait for the result and then invoke the next one. So this is kind of a domain-specific language to deal with synchronous stuff. How does it do it? It needs a generalization of all the different future-like things, including streams, including all other monads. And it just splits the code here and says, when this ends, so getUsername dot then, the rest of the code. And it's quite easy. But we don't need to stop on the serial schedule. You can, for example, have a condition which is again asynchronously executed if it's asynchronous, and then if it returns true, when the result arrives, start executing the body. And then you can really easily implement the while loop or, for example, branching, if, dot else, and everything. The problem here is that this doesn't really look like C++, but for me, code written in this way is much more easy to read than the callback soup that we had before. For this, we would need asynchronous operators, so value equals to 5 is not a normal equals. It's not a normal becomes. Again, since 5 is a synchronous value, it will be the normal equality. If value equals to some future, it will wait for it, and this will create a task that has its own dot then method or anything else. You can create something that is not in current C++ as a structure block. You can say execute these tasks in parallel. You can detach a task because you don't care about its returning value. Or you can define a for each for ranges, for streams, and everything else. You can define something a little bit more advanced. Instead of having normal tasks that you can just call, it's sometimes useful to have tasks that you can also undo. So something like command pattern, if anybody is into patterns. So you have a lot of tasks that have start and undo, or just operator bool. If it's true, it should perform something. If it's false, just cancel. If task 1 succeeds, we are going down. If, for example, task number 5 returns false, it failed, and you can just make transaction call to roll back all the previous tasks. So one of the things that I really love about functional programming is not all the purity or everything else. It's that you can define your own control structures. And here we're using functional style inside of C++ to define our own control structures that look like normal imperative programs. Okay, since I don't have a demo because this is not my computer, let's keep it. So if you want, for example, to write a WebSocket server, instead of, again, having a lot of code soup, you could do something like this. You are waiting for a client, and you're detaching a process to deal with the client. And if you're using Boost as IO, you don't even need to do it in multiple threads. All of this code can deal in a single thread with a lot of different clients. And this is still one single method. It's not spread out in a lot of different places. You can just write normal logic. When you get a client, do some communication with the client and do your stuff. And this, for me at least, looks like a normal algorithm. It's not difficult to reason about. If you ever try to write a proper server, have you tried to write a proper server? I guess you had a lot of different methods to deal with all of these things. At least when I implemented the Boost SIO version without these abstractions, it was really sucky. It was, I don't know how many hundreds of lines of code, and now you can just put it on a single slide, which is for me a big benefit. Okay, so this is the part that was covered in Berlin, maybe a little bit more in detail. The things that you also get when you switch to monadic-like iterative and programming like this is that you get your code much easier to test, much easier to verify, and similar things. So in this case, let's return to the mouse movements example. You have a normal code. This is a stream that will emit signals that mouse has moved in the future. You filter it, you transform it, and you call the on-mouse move. When you want to test asynchronous code, you usually need to write some complex testing framework which will wait for the results and everything else. In this case, you can just replace mouse movements. Instead of it being a stream, replace it with a standard list. And now you can test your whole logic for the synchronous parts. So instead of having something that will, when you move your mouse, it's a future, this thing allows you just to replace, without changing a single line of your code, just replace what mouse movements mean. Instead of having something that will arrive later, just put it already prepared data. So you can run your automated tests not on some future information, but already on prepared lists. The same thing here. Instead of, when you want to test your code, just provide it with alternative implementations of the asynchronous methods. Make them be synchronous. When you run your tests, you will not need to wait for anything. You will already have everything that you need. So this, without changing a single line of your code, makes it really easy to switch between asynchronous implementations and synchronous implementations for tests. The same thing for the WebSocket server. So when you want to test, first you have the agent tests, which will actually test whether your futures work correctly. On the other hand, you will have logic or integration tests, which will, instead of using future-based get username, will use the synchronous ones. So you run tests on synchronous data, and when you want to compile the final program, you have already tested this. You have already tested the main logic with synchronous mechanisms. Just compile the final program to use asynchronous ones. So it's like a compiler switch that makes compilers say, okay, I'm not going to use any asynchronous operations anymore. I'm going to switch and just compile normal code. The second part is something that I guess should be used more often. Instead of verifying your programs, you usually just test them. But in some industries like airplane industry and, I don't know, nuclear power plants and nuclear silos code, you actually need to prove that your code works correctly. And usually for that you need to, if the code is asynchronous, you need some complex logics like TLA plus, which is a temporal logic with actions, or cal, or I don't know how many mathematical theories were created in order to help you prove your asynchronous code. If you write your code in a way that was present here, you can do proving in the normal logic that you have learned in elementary school or high school or something else. You don't need any temporal logics for your code. And the third part is the static analysis that some of the sponsors provide. I haven't tried it with the Rainbow Unicorn. I've tried it with a Clang analyzer. So you have some code, and I guess it's quite obvious that something is wrong with it. Does anybody see what's wrong? Sorry? Yeah. If you don't go inside the if, this pointer will still be null pointer, and you would call right on a null pointer. And this is something that Clang analyzer can catch quite easily. So it says we have initialized the value to null, assuming that I is less than 0. This if will not be executed when you call value right. Said you're calling something on a null pointer. If you try to do the same thing for your callback program, what do you think that Clang will report? It's the same error. It's the same algorithm. It was just split into different parts because now we are going to be asynchronous. Unfortunately, Clang reports that there are no bugs in your code because it cannot know that there are bugs. Clang cannot know that you are not going to initialize somewhere else the value not to be null. If you call Clang analyzer on the code that is written with this kind of things, you will, unfortunately, it's not as detailed as the original one, but still it realizes this is a null pointer in this structure, which is a synchronous blah 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 structure called by these brackets here. When you call value right, it will complain that you have an error. Again, this is not asynchronous code. We switched all the asynchronous methods with synchronous ones, and as soon as we did that, like a compiler flag, Clang analyzer is able to actually reason about your code. The problem in the previous slide wasn't that this code is called is broken in a lot of different methods. It's that methods are actually scheduled to run somewhere later.
I guess that the references here is happening. Go back, please.
No, sorry?
It's happening only when assignment is already done, isn't it? So on the right there actually is no bug.
Yeah, I feel the same.
Where?
The same where that is
There is no bug at the right.
Okay, but trust me, yeah, I do get what you said. Sorry, but still Clang didn't recognize the error in the code, trust me. Okay, thank you for pointing that out. I need to fix it somewhere else as well. So here there is no bug as well. Let's continue. So one of the point here, although the example had a mistake, is that when you have a truly asynchronous code, no static analyzer can analyze it properly. If you switch it to be synchronous, then all the static analysis can work as it should. And now, I had a question in Berlin, what do I think about the await proposal? And I was really negative about it because I read only the first await proposal, which for me really sucked. And afterwards, when I heard about await 2.0, I kind of ignored it because the first one was really bad. But a few people, including Kaiser and Detlef, they said await 2.0 is really, really, really different. And after reading it, I can concur that it is. And it will be one of my favorite future features in C++ 17 if it arrives. So the idea is, if you have a monad here, or a method that returns some kind of monad, and call await on it, string HTML will not be a future. It will wait for the future, or if it's a different kind of monad, it will wait for result of that monad, and only afterwards continue with your code. Now, the original proposal did this mainly for the threading stuff and proper futures, but for nothing else. The new proposal is based on, okay, let's switch. If you write await something, you will get this kind of code. So let's check whether that expression is already here. It will call suspend. If it's not, if it is, it will just return the value. And these methods will be defined for std future, but for your own classes, you will be able to define your own methods. So it will not work only for the futures. You could make it work for lists. You could make it work for std option, std expected, and also a lot of different things. The only problem that I currently have with it is that it's still called await, because when you say await for an optional, it doesn't really make much sense. But at least we have a really powerful mechanism based on monads in C++. And for example, for the future, you can implement these methods quite easily. Await ready, f.isReady, and other things. The only downside that I see with await is that it still doesn't provide you with all the abstractions that you would be able to have if you define your own control structures. So for example, while this does work with all the options and everything else, you cannot implement, for example, the transaction scheduler that we saw earlier with awaits. And if you want anything even more advanced than the transaction scheduler, you will have problems. Await is really convenient for the control structures that C++ already provides. It will be convenient to implement your own control structures in an easier way than it's currently possible, but it could be even more generic, though I'm kind of satisfied by the current state. So our example from earlier, when something returns an option, instead of checking whether the result is correct, you would just await for the config value. If it returns an empty option, you just immediately go out of the method. Again, if you await for the parseInt, if it's an empty option, it will go out. Otherwise, it will return optional string. So await doesn't allow you to go out of a monad. It forces you to stay in the monad that you're using. So our original method was just string get query limit. Now you actually have to write to return the monad that you're using above. I'm out of time. Okay, so this is the implementation. And it's really tedious template stuff, so if anybody wants, I can send the slides, or the slides will be posted, right? Okay. And this is for, like all teachers, I need to tell you what to further to read and to watch. These things are a definite good read. Starting with iterators must go. And everything else that Alexei Alexandrescu ever talked about. Okay, am I completely out of time? Okay.
I've got two questions. What was the biggest problem, biggest project in lines of code in which you used this approach?
Okay, that's the same question I got in Berlin. So I'm already prepared. This was invented when we had some project in KDE which had to do with a lot of asynchronous stuff. The project itself back then, I don't know, it was, I guess, 2,000 lines or something like that. I really can't remember the size of the code. But it was kind of soup of communicating with external services. So essentially, all the code was only, it didn't do anything apart from getting the data and sending the data. Mm-hmm. So the main code was only the problem with the spaghetti code.
So this thing is actually working in KDE, am I right?
That's the second question that I got in Berlin. No, because I deleted the code. Because it was a feature that was sponsored by a company regarding encryption and stuff like that. And after a while, I got fed up with that part of the project and realized that encryption cannot work like they wanted to for it to work. So in the last versions, I just cleansed my code out of all of that.
Okay. And the second question, are there any real-world constraints that prevent you from just using functional programming instead of recreating it in C++ code? Why would you do that?
Yes, because it's not C++.
Well, but it's not a constraint.
It is. It really is. So a lot of, first, a lot of people use C++ and are based on C++. And C++ gives you performance that functional programming languages don't. These concepts don't slow up your code. So everything that you saw is the compilers unwrap all the templates that you use and actually create the same assembly code as the right-hand side with call and callbacks had.
Have you made any comparisons between stuff written in this style in C++ and any functional language, Haskell or Erlang or whatever? How slow are functional languages than this approach?
Well, in general, since this is the same assembly as normal C++, then they're as slower in the same amount than normal C++ programs.
Okay, thanks.
So one just addition. I love Haskell, I love Scala and everything else. But the problem is that here you have unbeatable performance and you can write your own. This is not functional programming. We are using functional programming to create a perfect procedural programming language.
Well, it doesn't look like a procedural programming language.
It has while, it has if, it has everything that you want it to have, just it's not called if, it's called if with an underscore. So the idea is to be able to recreate your own procedural programming languages, just replace with a little bit more awkward syntax.
You said that the only way is using this approach is to apply serial method, right? But it's not true, because currently you may use, for example, boost coroutine or boost context. Even boost ISO contains functionality that allows you to write down your program in a synchronous way, but it uses as an implementation an asynchronous calls. And your code can be written using coroutine, just simple as it we are doing using our synchronous approach. And you may even wait for some events because it doesn't block your thread.
Yeah.
And this approach is much simpler, I guess. So
again, a question that I'm usually asked is about coroutines, Boost coroutine. I do agree. The problem is that 99% of people have no idea how to use Boost coroutine. So if you, I don't know, how many of people in the audience actually use Boost coroutine? Only a couple of hands, right? So coroutines are a really, really powerful tool, but they allow you to do really bad things as well. And you can get them really wrong. When you, these things can be built on top of Boost coroutine as well. So the idea here is not to allow you only to do asynchronous stuff without blocking. It's also to allow you to write your code like it was a normal procedure without jumpings, yields, and everything else. The reason why I don't like coroutines in general is that they're really hard to debug in normal production code. You have no idea what terrors I have seen from real different companies who tried to use. So it was like they have 10 different methods, and each of the methods just jumps between each other because they have no organization. So Boost coroutines are perfect tool if you are strict in how you're using it. But anytime you give a random developer a coroutine, you will get the worst code that you have ever seen.
Okay, yeah, but if we, for example, ask people about using serial approach, I guess nobody said that.
Yeah, because it doesn't exist.
Right. So
in essence,
you know,
this library doesn't exist, just chunks of code, so it's obvious that nobody uses it, right? Although I've heard from somebody on this conference that after seeing my talk in Berlin a couple of years ago, which was something similar to this, they actually created something in their own company that looks like serial with continuations and everything else. So I do agree, nobody uses this stuff. So Boost coroutine is much more popular than.
Hi, I have a related question. So this is mostly a solution to the problem of expensive threads. And why not just fix threads?
Okay, I expected you to mention Go.
It wasn't me. It was you.
I'm joking. So fixing threads, I don't care about threads at all. So here it doesn't matter whether all the asynchronous stuff is thread-based, coroutine-based, it's a single thread but polling for events or something like that. This is an abstraction that can work with all other things. As I said, you can implement a web server in a single thread. Don't care about threads at all. I would love somebody to fix threads. I don't care about them. So for example, it's really popular nowadays to create task libraries because threads suck. And on the other hand, you have people like people from TypeSafe of Scala. They created their own reactive server which kind of doesn't use threads in an obvious way. It's actor-based system where you can send, like Erlang, if anybody used Erlang, send events from one actor to another and everything else. Now, are there threads in the background? Yes, but nobody sees them. And that's the reason why I don't want to mention thread as a specific thing in my talk.
But if you don't use threads, that's bad, right? Like, why don't you want to use threads, assuming that they're cheap?
I don't want to use them directly. I don't want to care what's the mechanism below myself that provides me with asynchronousness. So, for example, if you ask Google for some kind of search result, you don't care whether your operating system span out a thread and waits for each character to come back, or you have some kind of smarter operating system which just does select on your input. The only importance is that it's asynchronous.
Right, but we don't know what's underneath the threads as well, right? It's just an abstraction of abstraction for concurrency. You can build threads on top of the pollen as well.
Abstraction.
Sorry,
Because
what?
It's a really low-level abstraction.
Not necessary. It's exactly the same as yours. It's just a concurrent execution.
It's
you can
not
build it,
really.
You can build it on top of actually a single operating system kernel thread using select or equal.
Yes, you can build. Threads can be more abstract than they are currently, but I don't see what you would gain from them being more abstract.
More abstract, because I will be able to write what you've shown is just in plain C and just replace your detach with std
Okay,
thread.
you lost me at plain C, but the problem is that you would still have all the you would have to spin the threads, whatever that means for your lower operating system. And then you would need to somehow, for that thread, to send you back the information. And then you have call and call back. And then again, you're splitting one thing into 10 different things that don't need splitting up.
No, I just write it sequentially. This is a thread.
And if you want to call a synchronous operation from your thread, what do you do then?
I don't want to call asynchronous.
You need to. It's a common use case to have a task with a lot of subtasks. For example, you want to download all the images from Picasa. You first need to fetch the HTML, then in parallel to fetch all the images on that HTML. So it's a synchronous operation and a lot of additional synchronous operations inside it.
Hey guys, you should stop.